Welcome to my mustache at WICKERSON Studios. I am continuing with the examples, and we were stuck on curves right now. So we've managed to get through the basics, the geometry, and we're into the lines as that will start to develop in some more difficult algorithms. And then over here I just have tons of examples of kind of thrown on the canvas applications to playing within the viewport in Rhino. So we're going to work within our Ghpython nodes and stay focused on that. So let's just shrink this down. We may not be producing too many fancy geometries to start, but like anything, let's get in here. Let's go to the Maths tab and start with the one and only node we need to focus on, unless you want to try some C#. And let's open it up into the editor and see what we can do. Same thing as ever. Cut all this starting stuff because we don't know if we're going to need those inputs and those outputs. So just pull back your script that looks like an 11-line script, make it a 1-line script, and start with import Rhino script syntax as RS. I will be using in this one random, and just to save time typing, even though it's not that much, I'll just import that in as R. Begin with the points list, which most of these start with, because basically you need a container for something exciting, and then you'll try your iterations for I in range, and we'll set that range to whatever we want. Let's set that range so we could go up to 100, but let's just give it a I don't know what we want to call it. Let's just set it to RAN. Yeah, we'll just set it to cap. It's kind of becoming a habit of mine, which isn't good practice to change it from other people's, but I'm going to leave it as a cap because it's not the range that's being used as a function. It's actually being used as a variable. So I'm getting the habit of just writing those in, even though they slow me down a little bit. And I'll keep it as an integer because that's what seems to work well in the Ghpython node. So I can play with that and I can change that. And of course, since I brought it in, I probably should make good practice of just typing it in because I didn't want to go to 100. I want to start at something that can potentially go to 100 as an integer. 12 should be a nice beginning to that. Now we need to put something in the scope of that function, and we're going to do that by creating a point. We're going to set that equal to the Rhino script dot add point autocomplete, and we're going to do some fun things here with the random uniform. And we'll make that uniform go from 0 to x. So we'll give a variable for x because that's kind of the direction it's going to be going in a point. We'll do an R uniform in the y, and we will do even, no, let's keep it flat because we're going to find out this whole program itself is going to be finding out if points are within a curve, and that curve has to be planar in order for that function to work, at least as far as I know. So in saying so, we're definitely going to have to be inputting a planar curve. So I'm just going to type in here curve, planar, and keep it short. We'll just call it curve, and we'll know that it's planar because of the function. Because you get in the habit of knowing things a little better, and we'll do to the point and beyond, which will be curve points in curve. And that's it. And actually, we should say closed curve because it needs to be a closed curve in order to be inside. Otherwise, you'll run into problems as well. So there's a few little things you have to do there, and we'll make it as cap lock because we may make this one. What is the tool? There is inside-outside curve. You can find that in the analysis. We're copying a more complex node that's already on the Grasshopper, but it's good to learn how to write those. So that curve should not be spelled groove. Curve, and we will find a container for that, which I don't usually like to do, but for this one I definitely will. And I'm just going to start something simple and make that curve a circle. I don't think that'll be an issue. Sometimes circles can be an issue, but I don't think it'll be an issue for this one. Let me set that, and we'll draw that into the curve. And remember, our type hints have to match. I don't want it to be a circle. I want it to be recognized as a curve. That should be no problem. I've learned to put my microphone up so I don't sneeze and make a horrendous noise. We'll take this over to visibility and get it off. And we actually will take that curve and we will we will internalize it. That way we're not dependent on any 3DM files. So that's really the practice I've gotten into. Let's go back to our script editor and see where we're going to need a curve. What we're going to do is append the points list, which you should be getting in the habit of doing this with points. It seems to be similar each time. We will leave the scope of that function, and we're going to deal in a Boolean, not a conditional, else statement, if else statement. We're actually going to use the tool Boolean, but we're going to make a variable called Boolean, and we're going to make that a list. So we have a Boolean list, and we have point in, which will be a list, all the points that are within that list, and we have point out. And this should start to make a little sense to you, if you can think of it logically, what's happening. And I'm going to go through another iteration of for I in range of, now you have to use another function that's built in called length, because you want the length of the array of points that you made from those point constructions you made through the add point, uniform, and 0. So that's going to run through each of those points then. So for I in range length of points colon, which I think of it meaning then. I like to use that language for it. I say that in every video. Point in, and this is a long variable name, or we'll just say point in, in out, because it could be either. So that's a variable point in out. It's going to be a Rhino script of a function called point in planar. So somebody's already written this whole script for you. So it's like having a cluster in Grasshopper. They've already got that as a function, point in planar closed curve, which seems like a big name for something. It will require down here when you take a look, and just get in the habit of doing this because it'll get you better on the Rhino Common API when you have to go into it and find things that aren't built into Rhino script syntax, but this is a good place to begin. There's always an example down below. The only reason is I don't like it is because it plays into more of the Python editor and Rhino window. I don't use the get objects, which I've mentioned, because I actually set those as the curve, but you can follow this through, and if the example isn't the best thing to look at, you can always look in here and see what is given back to you, what it returns. 0 is the enumeration for points outside of curve, 1 is the points for inside a curve, and 2 is the point for in curve. But it's going to require a point, curve, plane, set at none, tolerance at none. But I will need points and a curve. So definitely I'm going to be setting my points within there. Fairly simple to start, but I want every point in that list. So to do that, I've got to use the variable I to get to every point in that list, and I will need my curve. And I think I set my curve with small c, so that should work. Now you're going to take the Boolean list that you set up, and it's not really dealing in a function Boolean or bool. It's just your variable name. You will append that list with the point in out variable, and hopefully that will run fine, and we haven't had any problems. And here's the conditional that comes in order to kind of enumerate through whether it's here, there, or on it. You've got if Boolean at every instance, or indices of it. I always jump up like that. I'm not sure why. Like I said, I think it's the sleeve of my shirt. Roll up my sleeves. Is equal to true, which means true if you think about being 1 and 0 being false. Then, with the colon, your point in will be appended, and that was that initial list, by the points at that variable that was satisfying that if conditional, that it was true. Then you're going to leave the scope of that, but you're still within the for loop scope. You're going to have if Boolean, and I guess I'm not going to have anything that's actually right on the line, which could very well occur, but let's see what happens, because then we'd have another point. Because it's equal to true or false, what happens because of the iteration I'm thinking about? Like, if you've got point 2, the point is on the curve. We actually haven't allowed for that in this function sample, so I may have to work that in later. Anyway, we've got to go through every instance within that. If that is equal to false, keep in mind with Python you're going to have to capitalize true and false in order to have it go into a keyword as opposed to C#, if you've been playing around with that. And then point out will be appended by the points at every instance. I don't know if that's the language people use, but it's the language I use. And leave the full scope of the function, give yourself a space, and output point in underscore out, which we have to make sure we put into our node as being equal to point in, not oint in, point in. And then point out will have to be underscore, will be set to point out. And if we set this right for point in, out, and point out, out, which is kind of an interesting, sounds Canadian to say that, point in underscore out, and point out underscore out. We'll see how we can jazz this up as long as our basic script is running. Let's pull a panel here to see that it's working. If it's working, then we can start grabbing a couple of containers for our points. But since I'm confident, even though I'm confident enough to know that I'll figure it out, but I bet you there's a little error in here just from a typo. Let's run the script, and there is an error. What's it say? Solution token colon if where on what line, because it tells you more here on 14. It's usually a case of something above it. Point I in range length points. You can see right here it should have had another it should have had another parentheses to end it, and that's why that colon was causing a problem. And now I have variables causing trouble, obviously, because I did not for my x and y, I did not put in my x and y, so we're going to add one here, and we are going to set these to type hints integers, because I didn't have all my inputs inputted. And I don't mind missing this a little bit, and because I wanted those to climb up to 10, I will set them as a slider in the x, and I will set one in the y to, and because I had it coded in as 10, it's not going to kill me to keep those. They're small enough numbers. Let's run it. And now I have another problem. Exactly 3 arguments must be given in line 7. And you can see what happened here. I have 1, I have 2, and I have 3. And I did not have my 0 range through to my y. And there we go. We got it up and running. The points out are not being read because I believe if we take a look, all the points are in that circle because that is such a small range of points. Now, what happens? How can we fix that? Because we're playing at such a small number, let's just make this range. That's not going to make it bigger. That's going to make the range, but my x and y have to be climbing much higher. So let's take the variables of this. The other solution, I'll show you in a second. Let's take this up to 110. And let's take this one up to 110. And you'll see that I can grow it and make the equation work. I can stretch that out in this direction, stretch it out in this direction. Then I can go back to my original circle. I can make it visible. Actually, I think I put it on hidden, but it should be there now. I can certainly play around with this curve. And because it is just a curve and the circle was just to get us started, why don't I just go in here on a top view and just draw out a curve that's just loop-de-loop. That kind of form fits that in that direction. And I can take that curve and say, let's put that one right into here. And there we go. It should be running. And we can do-si-do get rid of that one. Nothing's hard-coded. Our curve is in there. I'm going to go to top view because we're only dealing in 2 dimensions. And we're running this script. And these are the points that are outside. And these are the points that are inside. And we do have one. Well, that's interesting. Why is that not 1 point? Well, once again, this point that's driven me crazy forever is coming through this massive script, so you have to ignore this little point. And I apologize for that, but I have yet to figure out, as I test this, where that point is. Let's take everything to disable. And for the life of me, I can't get rid of that point. And I have no idea why. It's just like this ghost in the machine is like this point. It's like, I'm never going to tell you exactly where I am. I'm at 0, 0, 0, and I have yet to figure out where in this script, when it's all turned off, that is actually running. So that's just something that's causing me a little pain, but I don't mind it. Don't include that point. If I found it, I'd put a big sphere on it and we'd know what it is. But let's jump in here and make this enable. And so imagine every other point involved, looking at these points. Out of those points, you've got if you think about it this way, out of these points, the blue points, these are the ones that are inside, these are the ones that are outside. And that's how that script's running. And of course, I can change, I can move these points and rerun it every time. And it's jostling around. And you can go back in and you can have fun with this little scaled object. You cannot do something like this because it's not written in the script. I probably should get more complex when I'm dealing with this. I could go in and grab a couple points, but if I do that, I believe, or at least I thought it would have failed. Let's go back to top view because I've made it not planar. It still functions, but it's projecting to a plane. It must be working off of, the script must be working off the XY plane because that doesn't make sense to say those are in the curve if you're dealing with it on this angle, looking at it from the right or the side. So it really doesn't break when the curve kind of comes up in a way. But it was really meant for like a 2D kind of application of seeing if those were contained within or not. So they're all within, and at that point you'd have to pull some up and make sure they pop outside. And maybe by the end of this series I'll figure out where that little 1 is do-si-doing around to and why that comes into my script. And I'm going to leave it as a mystery, and that'll be the reason people will have to sign up and get these files off my GitHub and play with it. And yeah, that's a pretty simple example. You can start playing with any of this information as you go in, but that basic point in curve is how we're going to end curves, and we're going to do-si-do over into vectors now and see what kind of geometries we can come up with this. We're going to start with vectors, move into copying and moving objects through scripts, and then getting into attractors. Anyhow, thanks again for watching. Not too exciting, but I don't know. Let's see how exciting the next section is going to be by just putting all these on enable, and that's going to take a second to go. Yeah, it is going to be a little more exciting. You can see what we're starting to generate, a whole bunch of data and rippling forms and lines and curves, and it should be pretty fun to get in here and see what's necessary to be doing these things. So I'm very happy to continue this series to the point and beyond. The Ghpython node at WICKERSON Studios with applications to all of these examples.